Hi everybody, welcome to the second of 3 videos covering section 2.3, where we will be using technology, specifically our handy dandy TI-84 series calculator to solve quadratic functions. And here we are going to go over a number of examples which are uniquely tied or specifically tied to your homework assignment. And here is the first one. Solve the equation f of x is equal to 5 if f of x is equal to 0.6x squared plus 3x plus 4. Okay, now that sounds kind of like a lot, but really this is what they're saying. They basically want f of x to be equal to 5, okay, right there, and they want, assuming that that's this, and that's just a nice way of saying that they want you to solve 5 is equal to 0.6 x squared plus 3x plus 4. And so you could do that analytically, or you could do that using a calculator. Now, using a calculator, this is what we're planning on doing. We are going to plot f of x is equal to 5. What's that going to give us? That is going to give us a horizontal line at y is equal to 5 for all values of x. So whatever the value of x is, y is equal to 5. And then we are going to plot the curve f of x is equal to, well, right up there, 0.6x squared plus 3x plus 4. Now, the 2 points, the 1 or 2 points where these two curves intersect is the solution to these two equations. And that's basically our plan. And to do that, we are going to use our calculator. And how will we do that? Well, the first thing is you want to come up here and you want to hit y equals. All right, there it is. And we don't really want that, so let's get rid of that. And what I'm going to do is I'm going to put in our first equation, which is y is equal to 5. Okay, I'm going to hit enter. Now, before I do that, I'm going to go ahead and plot this. Now, before I plot that, I want to look at my window, because this basically tells me what values of x and y that's going to be looking at. And for this, what I want to do is I want to start off I want to have the x range from negative 10 to 10. So I'm going to change x min from 0 to negative 10. And x max to 10. I want the scale, well, no, I don't want that. That will mess me up. I want the scale to be 1. And the same thing with y. Y min negative 10. Y max 10. Scale 1. Okay, and now I want to graph this. I can do that by hitting graph. And there it is. That is 5. 1, 2, 3, 4, 5. Okay, so let's come back over to y equals. And then in the second equation, y2, and the way I can get there is by using my cursor. I want to type in this equation right here. And how would I do that? Well, I want to type in 0. I want to basically have this on the other side of the y. And I can do it as follows, 0.6. Now, this is my variable. This is the button that I want to use for x. Okay, and since I want to square it, well, there's our square key. Just hit that. So I have 0.6 x squared plus 3. You can do times, you don't have to. Once again, x plus 4. Okay. Now, if I have my windows set correctly, we should be able to see everything. And if I don't, we'll probably need to adjust the window. So let's go over here and hit graph. And there we are. Now notice that the equation that the solutions to the equation are where the two lines intersect. They're here to here. But we need to compute those to 4 decimal places. Actually, let me make this a little bigger over here. Okay, and we can do that. Now you can't do that by sight, but the calculator has tools which will allow you to do that. And those tools are found under this key called Calc right there. And you can access it by doing second, and then trace or calc. And notice that one of the enters here is intersect. That's what we're looking for. So let's go down there and hit intersect, because remember, they're satisfied when those two graphs intersect, and hit enter. And now notice here, you're asking for the first curve. And notice now, in this particular case, the little cursor here is on the blue curve. Cool, let's hit enter. All right, now we're on the second curve, and here's the other tick that shows the second curve the way we want it. So to hit enter, and now we need to guess. And pretty much what you want to do, notice that there are two solutions. You want to make sure that your blinking cursor right there is closer to one solution than the other. And there it is. And we can hit enter. Okay? And that right there, our x value right there, is the answer we're looking for. Now we want the 4 decimal places. 1, 2, 3, 4. Okay, 0.3136. And since this one's a 5, we are going to round up to 0.3137. So our calculator is giving us 0.31365 with some other stuff. Now, since this is 5 or higher, that means we want to round this to 0.3137. Okay. Now, notice there are two solutions. We need to find the other one. How do we do that? The exact same way we did it before. Second, calc, intersect. Okay. First curve, that's the blue one. Hit enter. The second curve is the red one. Okay, but now for a guess, we can't guess here, because if we do, it's going to guess that point right there. So we want to come all the way around so that's closer to this intersection than that intersection. So we can use it. We can basically use this cursor right here to move it around. I think once we get it over the hump, there we go. We can hit enter, and there is our answer. So for this one, we have negative 5.31365, and that will round to negative 5.3137. Okay, so that's how you can use technology to figure out example 5. For example 6, you want to find the maximum of the equation f of x is equal to 300x minus 11x squared plus 2 to 4 decimal places, so you want to do it graphically. Now, before we do that, it might be good to put this in standard form, and that's what we did here. Okay, once you've done that, we can figure out what h is. And it turns out that h is going to be negative b over 2a, which is 300 over 22. We can actually then figure out what the max is. And we don't really need to do that graphically, although we will, but we're going to do that by essentially plugging in, by essentially using this particular equation. So let's go ahead and do that. So we're going to have negative 11 times, now that right there is the x coordinate for the vertex, x squared plus 300 times, so once again that's x, plus 2. And that right there is our maximum. The maximum will be 2047.4545. Okay, and that occurs when, so that's that's k, and that occurs when x is equal to 13.6364. Okay, rounding that up. Now, how would you do that graphically? So remember, this is the x coordinate, this is the y coordinate. Well, what you could do is come over here and actually punch that equation in, which is what we have here, and then hit graph. And notice you can't see anything. All you see is this big vertical line, and that is because the window ranges from negative 10 to 10 in the x direction, and from negative 10 to 10 in the y direction. And the max occurs at 13. So the max occurs somewhere over here. We don't know where it is. So we need to figure out where that is. Now, one of the things that you can do is you can modify the window, or you can come over here, okay, to zoom. Okay, and then we have a number of options here. We have box and zooming in and out, square, standard, and also we have zoom fit. Now zoom fit's not perfect, but it's a good start. So let's go ahead and hit zoom fit, hit enter, and that is our graph, which really does us no good. But what we do know is that the maximum is at 13. So what we probably want to do is go back into window, and we want to have our x values, the minimum, be something less than 13, say -10, or how about just 0. And then we want this to be greater than 13, say twice 13, 26, or let's just go with 30. And we also know, based upon what we've done before, is that the maximum is going to be 2047. All right, so with that in mind, that's definitely greater than 0. But we also want y max to be greater than 2047. So let's make that 2500. Not 1500, 2500. The idea here is you want to increase the window so that we can see the entire graph. And there we are. We can now see the entire graph. Once we've seen the entire graph, then we can use that graph to find the max. And how will we do that? Using the calc function right here. Second, calc, maximum. That's what we want. So we can come over here, hit maximum, highlight it. Boom. Now, notice the question here says left bound. So we want to pick a point on the left side of the maximum. You know the maximum is right there. We don't know what it is, but it's right there. So let's pick a point on the other side of that. So what we're going to do is we're going to move the cursor toward the other side of the hump. That looks about good. Okay, hit enter. Now we want to get the right side of the hump. Okay, that's about the right side of the hump right there, right? Okay, so the max is somewhere in between. Now we need to guess. And really all you need to do is pick any point between these two lines, and that will be perfectly fine. So we can click right there. That's a good guess. Hit enter. And that is our value for the max. And notice, what do we get? We get 2047.4545. Exactly what we are looking for. Okay? So the basic trick here is just to make sure your window size is large enough so that you can actually see the entire graph. And sometimes a little pre-calculation, like knowing, I guess answering the question analytically, would be helpful if you wanted to do this in a digital way. Okay, so now we can move on to our next problem, which is solve the following graphic equation to do decimal spaces using a graphing calculator. And basically, we want to find all those values of x where 1.9 x squared minus 1.5x minus 5.6 is less than or equal to 0. Okay, so how can we do that? Well, the first thing is we want to actually graph that equation. Now notice that since we have 1.9 and we have 1.5 and 5.6, chances are that we can probably go to a standard window like we had in problem 1. But the first thing, I guess, would be to basically put the equation in. So here we are at the equation. We can clear that, and we can type in 1.9 x squared minus 1.5 x minus 5.6, and hit enter. Okay, let's say graph. Okay, well that tells me I screwed something up. 1.9 x squared minus 1.5x minus 5.6. No, that's right. That's good. Okay, it's less than 0. Okay, well that pretty much tells me that our box needs to change. So now what we could do is go to zoom, we could do zoom standard. And there you go. Because if you hit zoom standard, that puts us back to the window that we're used to, where the x ranges from -10 to 10 and y ranges from -10 to 10. And there's our graph. Now remember, we want to find all those values of x where this graph is less than 0. So that corresponds to these points right here, which is going to be, so it's going to be those values of x which are greater than that value, whatever that is, and less than that value. So we need to find out where this curve crosses the x-axis. And we can do that by doing second calc 0. We're looking for the two zeros. All right, so hit 0, hit enter. All right, and we want to find the left and right bound for each of the zeros. So let's come over here. And that's the left bound for this zero. Hit enter. All right, now for the right bound, get on the right-hand side of that, hit enter. And then for your guess, anywhere in between is perfectly fine. Hit enter. Okay, and the first zero is going to be -1.366. But since we are going to round the two decimal places, it's going to be -1.37. So it's going to be all values of x's strictly greater than that number. Because remember, this is a strict inequality. We don't want to know when it's equal to 0. We want to know when it's going to be strictly less than 0. And actually, technically, that is wrong. We should change that to 1.36. Why? Well, if this is 1.366, 1.37 is a little bit over here, which makes it greater than 0. Okay, now we need to find the other one. And we're going to do that the exact same way. Second calc, we're looking for a 0. All right, and now we need to move the left-hand bound somewhere over there. Okay, that's probably good enough. Hit enter. Right-hand bound, this has to get on the other side of the 0 right there. And now any point in between for our guess. That's good. Can't get much better than that, right? And there we go. Our 0 is going to be 2.156. You probably want to leave it at 2.15 because 2.16 is up over there. So we have that x is equal to 2.156. We probably want to leave that at 2.15. Now, if you actually did put in 2.16, MML will probably mark it correct, as will I, because you're practicing good rounding. You just need to understand that 2.16 is up here a little bit, okay? Which actually is, and there it's not there. That does not satisfy the inequality. So that's the only reason why we're making a distinction there. Okay, next we have an example where we need to analyze a quadratic and a linear function. This is tantamount to analyzing, say, a revenue function, which would be the quadratic, to your cost function, which would be linear if your cost function is basically modeled in terms of linear recurring costs. So here we are going to let f of x be equal to -0.8 x squared plus 72x, and g of x is going to be 0.12x plus 5.3. Okay, and we want to choose the correct graph. Now, one of the things that we can first do right away is basically ask ourselves, well, what are the y-intercepts? In other words, what happens when x is equal to 0? Well, in this case, when x is equal to 0, f is equal to 0. No, so the graph actually crosses the origin. Okay? In this particular one, when x is equal to 0, g is equal to 5.3. So at the y-intercept, on the y-axis, g should not be crossing the origin. It should be something greater than 5. And actually, let me bring this up a little bit. Okay, and also notice that here we have 2, 3, 4, 5, 6, 7, 8, 9 divisions between 0 and 18, which basically means that every single division is 2 units. So this is 2, 4, that's about 5.3. This is 2, 4, that's about 5.3. Now notice this graph right here, okay? Particularly the linear graph. The linear graph crosses the origin. According to this, it should not cross the origin, it should cross at 5.3. So this cannot be a correct graph. So this is wrong. Further, also notice that our linear function has a positive slope. This has a negative slope. This cannot be the correct function, or cannot be the correct graph, because the linear function has a negative slope. So this is out as well. And also the intercept is at negative 5.3, not positive 5.3. So the correct graph is either going to be this one or it's going to be this one. And how can we determine which one it is? Well, chances are the best way to do that is to actually plot both of the functions. Okay? And when we plot both of the functions, we need to know that x is only valid between 0 and 8. And that's going to come in handy for computing our windows. And also notice that our window maxes out at 8 and has a minimum at 4 for both of these. So we're going to use 4 and 8 for our y values, and 4 and 18 for our y values in our window, and 0 and 8 for our x values. Okay, so here we are back in our original graph, and what I want to, or back in our original setup, and what I want to do is I want to graph these two functions and figure out which one is closest, which graph is closest to the graph that comes up here. Okay, so let's go to y equals, let's clear this, and let's put in our quadratic, and that will be negative 0.8x squared plus 7.2x. There we go. All right, the next one is going to be 1.2 x plus 5.3. And I'm wondering, can I change colors here? Probably not. And hit enter. Okay, now we need to mess with our window. Now remember, we want, you can't see it now because this is a little too small, but remember we're going from 0 to 8. So we want x min to be 0, we want y min to be 8. Now for y, we're going to go from negative 4 to 18. All right, and now we can graph. And there we go. Notice how this curve still has not reached the x-axis when we were at 8. Kind of like the way this one does not. This one reaches the x-axis at 6. Okay, well, we don't have that. This is what we have. So this right here cannot be the graph. This must be the graph, and indeed it is. Okay, so that's the first part. But notice how we were able to get half of them just by paying attention to the how we could get eliminate half of them just by paying attention to the intercepts and also paying attention to the slopes. Okay, now let's go over the rest of this. Here we want to solve f of x is equal to g of x. Okay, how do we do that? Well, that should be 7.2. There we go. How do we do that? Well, basically, we do it. The solution to these two equations are where these lines intersect. And notice they intersect at 2 points. And that's what we're looking for. So what we want to do is we want to go to second, calc, intersect. Just like we did in the very first example. All right. First curve is a blue curve, enter. Second curve is a red curve, great. Now we need to guess. And if we want to guess over here, we want to get that cursor kind of closer to there. Okay, that looks like close enough to me. And we can guess, there it is. Okay, and the intersection occurs when x is equal to 1.022, which of course will round to 1.02. Okay, now we need to find the other one doing the exact same thing. Second, calc, 5 for intersect. Okay, it's identified the first curve. There's the blue one. Hit enter. Second curve. There we go. And now our guess needs to be somewhere over here. We basically want to be basically closer to the other intersection. So we'll just click a little bit. It's actually a lot faster on your calculator than this computer emulation. Okay, that should work. Hit enter. And here we have x is equal to 6.477. And that will round to 6.48. Once we have this, and of course once we have the graph, the rest of this is pretty straightforward. So for example, here we want to solve, we want to find those regions of x where f of x is greater than g of x. Well, we know they're equal here, right? Where are they greater? They're greater right here. Okay, so what is that? Well, that is going to be that is the values of x which are greater than 1.02 and less than 6.48. That is your answer in algebraic notation. If you wanted to do it in interval notation, which you might have to, that's going to be the open interval from 1.02 to 6.48. For D, we want to figure out those values of x where f of x is strictly less than g of x, i.e. when f of x is below the graph for g of x within our valid range between 0 and 8. Okay, well that's going to occur when x is greater than or equal to 0 and less than 1.02. That accounts for this range right here, unioned with the values of x that are strictly greater than 6.48. That should be an x, by the way. And less than or equal to 8. Now, in interval notation, that would look like this. That would be the half-open interval between 0 and 1.02, unioned with the half-open interval between 6.48 and 8. Sorry about my rising number there, but that should be 6.48. And that is all that I have for this particular video. Stay tuned for the last video when we do some real-life applications concerning specific business models. And until then, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.